All right, let's just dive right into it. Welcome to today's Explainer, where we're tackling one of the most fascinating and honestly critical upgrades in the cryptocurrency world, Bitcoin's Lightning Network. Now, if you follow the blockchain space at all, you already know Bitcoin is incredibly secure, but it's always had a major bottleneck when it comes to everyday scaling. So today, we're going to map out exactly how the Lightning Network acts as this revolutionary Layer 2 protocol, essentially transforming Bitcoin from a static store of value into a lightning-fast medium of exchange. To make this complex protocol a bit easier to digest, we're actually going to treat this explainer like a retro video game. We'll start with level 1 on the scalability problem, unlock layer 2 in level 2, trace the timeline in level 3, check out network power-ups in level 4, and finally tackle some side quests and the final boss in level 5. Let's get into it. So, level 1, the scalability problem. Think of the main Bitcoin network like, well, a highly secure, immutable save point in a video game. It is incredibly reliable, but getting there is slow. And here's the number that really highlights that fundamental bottleneck: 7. The main Bitcoin chain can only handle about 7 transactions per second. When you realize that new blocks take roughly 10 minutes to confirm, you instantly see the issue, right? Trying to buy a cup of coffee while paying a high on-chain fee and waiting 10 minutes just doesn't make any sense. The base layer was built for ultimate security, definitely not rapid-fire micropayments. Moving right along to level 2, unlocking layer 2. To completely bypass that 7-transaction limit, developers built an active gameplay layer right on top of the base code, which we call the Lightning Network. Let's break down the exact mechanics of how these bidirectional payment channels actually work. Step 1. 2 users open a channel by locking a set amount of Bitcoin into a multi-signature address on the main blockchain. This is essentially your initial save point. Then, step 2, and this is the genius part, they can now transact back and forth thousands of times totally off-chain. They do this by privately updating their balances through signed commitment transactions. They're basically just passing the cryptographic rights to that locked Bitcoin back and forth. Finally, step 3. Whenever they're completely done, they close the channel. Only that final net closing balance gets recorded back on the main Bitcoin blockchain. By keeping all those intermediate updates off-chain, the throughput absolutely skyrockets. Just look at the dramatic difference this layered approach makes. On-chain, Bitcoin needs 10-minute confirmations. Off-chain Lightning, it settles in milliseconds. We literally go from a hard limit of roughly 7 transactions per second to the potential for millions. And perhaps most importantly for us everyday users, those high network fees drop to mere fractions of a cent, often just a few satoshis. This right here is the breakthrough that makes buying a coffee or sending a tiny digital tip across the globe entirely viable. Which brings us to this mind-blowing number: millions. By pushing the vast bulk of activity off-chain and utilizing a web of interconnected channels to route payments, this layered scaling philosophy allows for massive parallel processing. The Lightning Network can theoretically handle millions of transactions per second. It fundamentally rewrites the math on what Bitcoin can do. Time to level up. Level 3, a retro development timeline. Now, the Lightning Network certainly didn't just appear out of thin air. The foundational concepts of payment channels actually trace all the way back to Bitcoin's creator, Satoshi Nakamoto, who had some really early ideas for updating transactions before confirmation. But practical execution faced some major technical hurdles, mainly something called transaction malleability. Then, in 2015, Joseph Poon and Thaddeus Dryja published the seminal Lightning Network whitepaper. This formalized the use of hash time-locked contracts, or HTLCs, for secure routing. Fast forward to 2017, and a crucial upgrade called segregated witness, or SegWit, activated on Bitcoin. This finally fixed that malleability issue and cleared the runway for Lightning. By 2018, Lightning Labs dropped the first beta of their software, LND, on the mainnet. And who could forget 2019's Lightning Torch campaign? It was this massive, incredibly fun adoption event where users passed micropayments of sats across the globe, eventually even reaching high-profile figures like Jack Dorsey. Up next, level 4, network power-ups and stats. So these power-ups are the specific technical attributes that give the network its edge. The crucial point here is how beautifully these features work together. We've already touched on speed and low fees, but look at privacy for a second. Lightning uses onion routing, which is heavily inspired by the Tor network, to completely hide payment details from intermediaries. A node routing a payment literally only knows the hop immediately before it, the hop after it, and the amount to forward. That's it. Then there's the security. The network uses Bitcoin's scripting with time locks and revocation keys. If someone actually tries to cheat by broadcasting an old, outdated commitment transaction, the network lets the other party claim all the funds via a penalty transaction. Boom. There are even third-party services called watchtowers that can monitor your channels while you're offline, ensuring no one tries to cheat you while you're away from your keyboard. And the network is constantly acquiring new abilities, too. Take Taproot assets, for example. This is a massive innovation that enables Bitcoin-native assets to ride on the Lightning Network. This means you could move stablecoins like USDT across the network with the exact same speed and low fees as regular Bitcoin. Combine that with other slick innovations like splicing, which lets you dynamically manage your channels without having to constantly close them, and atomic multipath payments, or AMP, which breaks larger payments into smaller, much more reliable pieces, and you've got a system that's becoming incredibly robust. Finally, we reach level 5, side quests and the final boss. This is where the code meets the real world. You know, every great technology has its fun early trivia. Back in the early mainnet beta days, users would constantly attach the hashtag reckless to their transactions. It was this fun little badge of honor acknowledging the risks of testing experimental software with actual real money. And even earlier than that, back in 2016, we saw the Lightning first strike on a testnet. Developer Christian Decker successfully bought a picture of a cat from Rusty Russell using an early prototype. Just a humble, feline beginning for a global financial network. But wow, look at how far those side quests have come since the cat picture. On a national level, El Salvador's adoption of Bitcoin as legal tender relies heavily on Lightning through apps like Strike and the Chivo wallet to process low-cost remittances. In the realm of high-profile purchases, remember Laszlo Heinetz, the guy famous for buying the first on-chain Bitcoin pizzas? Well, he actually used Lightning to buy pizza again in 2018. More recently, Donald Trump used the network to buy a burger. Furthermore, retail tech has evolved beautifully. We have protocols like LNURL creating seamless Lightning addresses and NFC integrations that make contactless crypto payments at physical stores a total reality. The network is impartially servicing nation-states, former presidents, and just everyday coffee buyers alike. And this chart brilliantly illustrates just how massive this has gotten. The sheer scale of this growth is staggering. By the mid-2020s, the Lightning Network boasted over 15,000 public nodes. Furthermore, the network's capacity, which is the amount of Bitcoin locked in channels ready to be routed, blew past 5,000 BTC. It has processed hundreds of millions of transactions, proving its resilience and proving that the real-world demand for scalable Bitcoin is absolutely there. However, as we all know, no game is complete without a final boss. For the Lightning Network, that boss is liquidity management and user experience. While Lightning obviously crushes it on privacy and speed, it does introduce some pretty complex friction. For example, nodes have to maintain balanced channels to route payments effectively. If all your funds end up pushed to one side of a channel, it just can't route payments in the opposite direction. Liquidity fragmentation, plus the difficulty of running true non-custodial setups without just relying on big centralized hubs, remain serious challenges. But developers are fighting this boss right now. They're building better pathfinding algorithms and creating liquidity service providers, or LSPs, to essentially abstract all that clunky complexity away from the average user. As the ecosystem matures and developers keep chipping away at the friction of that final boss, the potential is just massive. By anchoring its base security to the world's most robust blockchain and then innovating relentlessly on top, the Lightning Network is keeping Bitcoin's layered scaling philosophy very much alive. So I leave you with this. Will this Layer 2 protocol ultimately be the key to turning Bitcoin into the globe's default medium of exchange? The foundation is certainly there, and the network is growing every single day. Thank you so much for joining me on this explainer. Keep learning and keep exploring.